6 part B, the question says find the probability that two balls have different colors. What do they mean by that? You basically are supposed to take a ball at random from each bag. So they're comparing colors of balls across two bags. So if you take out a ball from here and it happens to be black, the question said it should have different colors. The second ball that you pick out from the second bag should be white. Now, why did we pick it out in this particular order? I mean, it could have been, instead of a black from the first bag, it could have been a white from the first bag and then a black from the second bag. Or probability of a white and then a black. That fulfills the condition too, right? So probability of black from the first bag is going to be, how many blacks do we have? Count with me. 1, 2, 3. We're going to say 3 out of total of 5. And means multiply white. How many whites do we have? Now remember this is from the second bag. 1, 2, 3. 3 out of 4. I hope it makes sense so far. They haven't specified which ball, which color you're supposed to take from the first bag and which color you're supposed to take from the second bag. They just told you that there should be different colors, and then this part of the question tells you one ball is to be taken from each bag. So if you have to select a second ball, it has to be from the second bag. Or means plus, add them up. Probability of white. Now the question has been reset. This is the first attempt or first try or first turn, whatever you want to call it. This is the second turn. At the second turn, the question have been reset. The balls are back in the bag. What is the probability of me getting a white ball? Because I'm studying that, right? That's what I've written down. Probability of white from the first bag. Probability of white from the first bag. There are only 2 whites, 2 out of total of 5. And means multiply. And what is the probability of me getting a black ball from the second bag? There's only 1 out of a total of 4. You solve this, it becomes 9 over 20, this becomes 2 over 20, you add them up, that becomes 11 over 20, and that is your answer. I can bring this down over here to avoid confusion. Remember, this is 6 part B, 6 part B. I was just solving it here so that it was easy to visualize right next to the question. Here it goes. Paul and Sammy take part in the race. Probability that Paul wins the race 935. Probability that Sammy wins the race is 26%. The only thing that's a little difficult over here to visualize or compare is this is in a fraction format. This is in a percentage format. How do we change a percentage to a fraction? Percent means per means that divided by a line. Whenever you write a fraction A over B, so that divide line stands for per. This is per, and let me write that down. This per means divided by, cent means 100, 26 over 100. Now we can compare this in 2 ways. Either we can convert both of these fractions into a decimal, or we can take the LCM. LCM is going to be a very long route. So let's just convert both of these to a decimal. And let me quickly calculate it for you. This is pretty easy. 26 over 100 basically becomes 0.26. If you're not familiar with this concept, decimal is over here. Divide means move to the left. 100 means 2 spaces because it has 2 zeros. I'm going through this concept really quickly because this is a grade 6 concept just taught in class 6, so I'm not supposed to be going in detail for that. 0.2571 and this is 0.26. So who is more likely to win the race? Obviously the value or the guy who has a higher probability, which is 0.26, which that happens to be Sammy. And I'm going to say Sammy. And why? Because he has a higher probability. Make sure you mention the word probability because this topic or this chapter is about probability, right? Next question. A bag contains 50 counters. Counters can be any article. Let's just say there are 50 items. 10 of them are red. One of the counters is taken from the bag at random. Draw a scale. 10 out of 50 represents the probability of getting a red counter. If you simplify this, this becomes 0.2, 1 over 5 or 0.2. How do I find out how much does each jump represent, each small jump in this line represent? What I'm going to do is take this entire value 1 and divide it with the number of small lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10. 1 divided by 10 is 0.1. Let me write that clearly. Apologies for that. 1 divided by 10 is 0.1. Every single small jump represents 0.1. So if this is 0.1, this must be 0.2. I'm supposed to draw an arrow right above this. Make sure it's accurate. Like this. Question number 9. Probability that Jane wins this game is 7 by 10. We discussed this concept many times. Probability of not winning is going to be simply 1 minus that above value. Where did this 1 come from? 1 represents 100% or a complete value, right? Probability scale, the maximum value in a probability scale is 1. So if you take the LCM, there's a 1 over here, you multiply this with 10 to make it equal to the denominator of the other fraction. 10 minus 7 over 10, that's 3 over 10. You could have done that mentally as well. 7 out of 10 parts are gone. There are only 3 parts out of 10 left. The probability that the train is late, same question, similar question. Only thing is this is in decimals. Decimal. So 1 minus 0.15, I believe that will give us 0.85. You can either use a calculator for that. It is allowed in IGCSE. Probability that Alex wins the prize is 0.25. Find the probability that Alex does not win the prize. Once again, I've accumulated a couple of similar looking questions just so that you can get familiar with the concept of subtracting previous answer or an answer of a value that is given which you do not require, but you need the other thing. So does not win, we have to find, and probability that he does win is 0.27. So I'm simply going to subtract 0.27 from 1, and if and when I do that, I get 0.73, and that is your answer. The probability that a tin of paint is is dented. So basically a tin of paint, instead of being a perfect tin of paint, it is dented. 0.07. So that's the probability of selecting one tin of paint which is dented. If you are selecting it out of 3,000, I mean, if you go into a warehouse, you're the manager of a certain place, and you're trying to figure out how much of my stock is accurate or perfect, and how much of it is dented, how much of it I cannot sell, or it's not proper, it's not perfect. So what you're going to do is simply multiply the probability of one item into the quantity. If I multiply this with 3000, I will probably get 210. This 210 is the how many? Quantity of tins that are going to be dented. If my stock, instead of being 1 tin, is 3000 tins, 210 of them are going to be dented. Why is that? Although I'm not supposed to write the answer like this, because the question does not say probability, but I can show you this is going to give us the same probability. It does. This comes out to be 0.07. Same probability that you have for one item. Find the relative frequency. We've discussed this in the lessons that I've uploaded. Relative frequency is just another name for probability. And it is a certain type of probability. It's experimental probability, not theoretical. Theoretical is what you study in the book. Experimental is when you actually carry out the experiment. The two are quite different things. Find the probability of scoring a 5 with this spinner. This is 5. Kim has a 6-sided spinner numbered 1 to 6, so it's kind of like a die. She spins it 63 times, and the scores are shown in the table. Alright. Find the relative frequency of scoring a 5 with the spinner. 8 over 63, and we can't simplify that any further. We can't. So that's the probability of scoring a 5. Work out the mean score. Now, how do we calculate mean? Although that technically does not come under the topic of probability, but since questions in CIEs can come across multiple topics, so we're supposed to be doing this as well. What we're going to do is multiply these two values, make a new row over here, label it sigma fx. Sorry, just fx. This is the value of x, this is the value of f, and if you write f into x, that means you're multiplying them together. 2 into 7 is 14, 3 into 5 is 45, 4 into 11 is 44, 5 into 8 is 40, 6 into 10 is 60. I'm not going to explain this concept why I've done this, because this is once again a part of statistics, which is a topic for another day. In fact, it's already uploaded on my YouTube channel. 12 plus 14 plus 45 plus 44 plus 40 plus 60. That gives us 215. You call this value sigma fx. So this goes in the numerator, 215. Sigma f is already written over there. Or in other words, you can add this particular row and get that number, and that will come out to be 63. If you divide 215 by 63, you get 3.412, and that's your mean score. Read this question, give it some time. Random sample of 200 families was taken from the families in a city. The number of children in each family was recorded. The results are shown in the table. Take a quick look at the table. Number of children in each family. How many families have 0 children? 25. How many families have, let's say, 4 children? 13. Similarly, how many families have 5 or more children? And that's 6. Find the relative frequency. Once again, relative frequency refers to experimental probability of families with 2 children. So if you carried out an experiment, it's relative frequency or it's probability. Find the relative frequency of families with 2 children. So this number would represent families with 2 children, and relative frequency basically means probability. 73 divided by total of 200 families. This column, if this row, if I add this up, this is going to be equals to 200. So 73 divided by 200 would give us, in fact I can leave this answer like this because it is a probability question. Let me quickly compare the answers as well. Yep, so far so good. Alright. There are 5,400 families in the city. Find an estimate of the number of families with 2 children. So instead of saying there are 200 families, remember, they initially said there are 200 families. Now they're saying there are 5,400 families in the city. Find an estimate of the number. They're not asking for the probability, they're asking for the quantity of the number of families with 2 children. If 73 out of 200 represents the probability for 200 families, if I multiply that with 5,400, would I end up with the correct number? Let's quickly put that to the test. 73 divided by 200 gives us 0.365. Divide that with, apologies for this, I'll explain what I've just done. Multiply that with 5,400, that gives us 1971. This 73 over 200, what was it representing? The probability of randomly selecting a family from a city which happens to have 2 children. And now they're saying instead of 200 families, which is the total, which is in the denominator, they're saying it's 5,400 families. That's kind of like saying, when I ask you to change 3 by 4, or let's take an easier example, 1 by 2 into percentage. What do? You simply multiply it with 100. And you say this becomes 50%. So basically whatever value you're supposed to be changing it into, percent means out of 100. So that's why I multiplied with 100. When it says 5,400 families, or basically per 5,400 or out of 5,400, I simply multiplied with 5,400. And 1971 is the number of families which are roughly going to have the same number of children that we're looking for, which is 2. The probability that Jane wins a game is 7 by 10. This is a similar concept connected to the previous one. This is the probability of winning a game. A represents the quantity 1. If she plays it 50 times, the probability isn't going to change. It's simply going to just multiply it with 50 because that event is happening 50 times. 10 ones are, 10 fives are, and that's just me mentioning the table of 10, 7 5 to 35. What is the number of times she's expected to win the game because she's playing it 50 times? 35 out of 50. But I'm not supposed to be mentioning the probability. They're asking the number. Let's just simply mention the quantity. Sophia has a bag containing 8 blue beads and 7 red beads only. She takes one bead out of the bag and randomly places it. She does this 90 times. Find the number of times she expects to take a red bead. Now let's try to visualize it. She has a bag containing 8 blue beads. 1, 2, 3, 4, 5, 6, 7, 8. These are blue beads. We go 7 red. 1, 2, 3, 4, 5, 6, 7. She takes one bead out of the bag at random and replaces it. She takes out one and then she puts it back. She does this 90 times. Find out the number of times she expects to take a red bead. The probability of selecting a red bead at one particular time, at one attempt, in the first attempt, at one only attempt, in fact, not the first attempt, is how many? 7 out of a total of 15. That's the probability of selecting a red bead. Simple. Once. If she does this 90 times, you simply multiply it with 90. This is a similar concept which we've been applying in the past. How many questions? 4, I guess. 7 divided by 15 into 90. That gives us 42. The probability that Tommy has his calculator for his mathematics lessons is 0.4, so he's not usually bringing the calculator with him. There are 120 mathematics lessons in 1 year. Work out an estimate of the number. 0.4 is the probability of him bringing a calculator to his lesson. Any particular one lesson. If there are 120 lessons, just simply multiply it with that value, and what do you end up with? 12 4s are 48. And you move one space, 480. You may move one space back, that becomes 48. 48.0, or simply mention 48. The last question, probability that Kim wins a game is 0.72. In 1 year, Kim will play 225 games. Work out an estimate of the number of games Kim will win. You simply multiply this value with 225. Why? 0.72 is the probability of winning one game. 225 is the quantity of games that she is playing. And I'm guessing Kim is a girl's name. Anyways, so you multiply 225, which is the quantity of times that she's playing a game. The probability won't change. Every single time the probability is going to be the same. You simply multiply that to end up with the answer 162. Hope it made sense. Khuda Hafiz and take care.